2, 3.
Hi.
Hey.
I'll go my name.
Well,
hi.
you can just say hi. And then...
My name's Josh. I contributed by creating the synthesis with Armand and creating the compound images.
Hey, my name's Armand, and how I contributed was I helped with creating the synthesis, and I also helped with filming and editing the video portion.
Hi, I'm Rochelle, and I helped write the script and do all the animation.
For our final product, we decided to use dibutyl ether. Now, the reason why we chose this product is because ethers remind us of Pokemon. In Pokemon, ethers are used to revive the power points of a Pokemon. And power points are how many times a Pokemon can attack with a certain move. Our final product contains an ether group, which is an oxygen atom that is connected to either an alkyl or an aryl group. In our case, our oxygen is connected to 2 alkyl groups.
We chose this molecule because it resembles Zubat, which is a Pokemon, if you didn't know that.
Which I'll see later.
And I'll show you a picture of it right now.
If we start with butanol, the reaction mechanism is fairly simple. First 2 steps are to synthesize an alkoxide ion and an alkyl halide, which then reacts with DMSO and heat to create the ether. This is also known as Williamson ether synthesis. When we start with malonic ester, we can synthesize an alcohol for Williamson ether synthesis. An enolate intermediate is involved when the ester is deprotonated. Enolates are great nucleophiles which are used to form a new carbon-to-carbon bond with an alkyl halide by SN2. Then 2 carboxylic acids are formed after hydrolysis, which then undergo decarboxylation under heat to form an enol and carbon dioxide. Because the enol isn't stable, it tautomerizes back to the carboxylic acid. The last step for making an alcohol is to reduce the carboxylic acid. The carboxylic acid is deprotonated, making it susceptible for nucleophilic attack by the hydride anion. The oxygen is then removed, which creates the intermediate, an aldehyde. The aldehyde undergoes nucleophilic attack, and the alkoxide ion that is created is protonated to produce the alcohol.
project was really fun because it was really interesting to see like what we could make with the knowledge that we gained from a whole year of taking OChem. And also, so when trying to find images online of some of the compounds that we're talking about, it was really hard to find them. So I found this program that actually helps me to draw them, and working that program out and like figuring out how to use it was kind of time consuming, but actually really interesting.
What was interesting for me about this project was applying a Pokemon storyline to our mechanism, and I really had fun experimenting with PowerPoint and like figuring out how to do animations to make it look like Pokemon, and yeah, it was fun.
What I found interesting in doing this project was that it made OChem more interesting and fun to learn, in the sense that we used other methods other than just writing out the compounds. But also writing out the compounds was pretty fun as well, because I also got to learn the different mechanisms that are used and made a better understanding of how it works. Oh, how we learn.
Relearn.
We learn.
No. Get it? Because you're like, learn how the mechanism, whatever.
Oh.